Hello guys, welcome to Concentrate Academy. In this video, I'm going to show you how to reduce sets to their basic form. Now there are some few things that I want you to take note of in this video. The first is the concept of irrational numbers, then followed by integers, then some common properties of sets, then finally obtaining the basic form of a set. So let's start with irrational numbers. Irrational numbers are real numbers that can't be written as a simple fraction. Now these numbers are basically non-terminating and non-recurring in the sense that they do not end. So for example, we could have square root of 7, we could have pi, and pi gives us 3.142 and it goes on and on and on. These are irrational numbers. Integers are positive or negative whole numbers. There's no fractions involved, so you can have minus 12, 15, minus 25 and so on. Then some common properties of sets. Now there are other properties of sets, okay, but for the sake of this video I just covered 3 because these are the most important ones you need to know in order to reduce sets to their basic form. The first one is square root of b times square root of b, which is equal to square root of b all squared equals b. Now, the square caters for the square root, hence b having b. So that's for property number 1. Now for property number 2, we have square root of b times square root of c equals square root of bc. Take note here, as long as they are multiplying, if you have different digits or different variables under different square roots, they can all come under one square root as long as they are multiplying. And for property 3, we have b times square root of c, which gives b root c. So the only difference here is that the multiplication sign just leaves, but they are still multiplying. So but the final answer is b root c. Now let's move on to obtaining the basic form of a set. So our set is of the form square root of a equals b square root of c, where a is the set which is not in its basic form. Then b is a perfect square integer and a factor of a. Remember, we already said our integer is what? A positive or negative whole number. Now b being a perfect square simply means b multiplying itself. So for example, 2 times 2. 2 is a perfect square, 4 is a perfect square, 4 times 4. And all these numbers must be factors of a. And c is also an integer and a factor of a. Now we're going to understand more of this when we take an example. So let's move on to example 1. Example 1. Square root of 108. Now over here, our set form, as we discussed, is supposed to be in the form b root c. So over here, you need to make sure you find out factors such that you can get a perfect square integer and another integer. In this example, we have 36 times 3. 36 times 3 will give you 108. However, with 36, we have a perfect square integer which is 6 times 6. So 6 times 6 times 3 gives us 108, which is what we have broken down over here. Now this can also be written as square root of 6 all squared times square root of 3. This right here is an example of property 2 as we have stated in the question. This alone here features property 1. Just this one, square root of 6 all squared, property 1, which gives what? 6 times square root of 3, and our final answer is 6 root 3. So this is the basic form of the set square root of 108. Now let's take a final example and we'll bring this tutorial to an end. Example 2. Example 2. Square root of 75. Square root of 75 can be written as what? 25 times 3. That gives 75. And 25 has a perfect square number, which is 5. Hence, square root of 75 is now 5 times 5, which makes the 25 times 3. So square root of 5 all squared times square root of 3 gives us our final answer as 5 root 3. If you like this video, give me a like, subscribe, and hit the notification bell so that anytime that I release a new video, you will be notified. I love you very much, and I'll see you again in my next tutorial. Bye bye.